Hello everyone. My name is Ragesh Hajela. I work as a senior AI developer and evangelist at Intel Corporation. And this session, welcome to the session. It's titled as NLP and Dynamic Shapes using OpenVINO. So welcome to the session. Uh, First, a brief agenda of this session. I'll be giving a quick overview of OpenVINO Toolkit, and then I'll be talking about how in NLP use cases we can leverage the power of dynamic shapes. How Intel and OpenVINO has built a solution which we can use for NLP use cases in terms of dynamic shapes, and then we'll showcase some of the NLP examples using OpenVINO. What are some of the popular use cases which we are powering with OpenVINO, and quick resources and Q&As. So first up, an introduction of OpenVINO Toolkit. So right now, the challenges with deep learning are both in terms of development as well as deployment challenges. In terms of development challenges, uh, we have unique inferencing needs, and there is a gap in performance and accuracy between the trained and the deployed models. So from the development phase, when we move to the deployment phase, we see all these different challenges, which are more about we want to make uh, models high performant, and we want to make models very efficient when they are running in production on edge devices. The second is we face many integration challenges because there's no way to streamline end-to-end development workflow, and there's a lot of time which goes into uh, taking taking models into products and into the market. The next thing is no one size fits all. So the solutions which we are building, how do we make sure that it's able to integrate really well with the industry standards and into a real product? So these are a few of the challenges which we face. Now, how OpenVINO Toolkit can help us is it's a it's a product which can help you to build, optimize, and deploy your machine learning models. It helps you with inference acceleration. Take any of the popular deep learning models. Let's say you have built with TensorFlow, PyTorch, Keras, Onyx, Paddle, Cafe. So all these models, once you have built in, then you have to take it to the production, and any of the Intel hardware if you are using, you will be able to optimize the power of the deep learning models on the deployed edge devices. So OpenVINO Toolkit helps you to convert and optimize models and deploy across all the mix of Intel hardware and environments. It also supports on-premises and on-device in the browser or in the cloud. Now, OpenVINO developer journey. If you're building your solutions with OpenVINO, let's say you have a trained model available with you. Now you want to uh, first of all, we have lots of trained models available. We have optimized pre-trained models available in Open Model Zoo, so you can leverage those for your popular use cases. And then we there's a section called optimize. So that's the second step, which helps you to optimize your model, load your model efficiently, make a better, efficient representations of your model. You can also use a post-training optimization tool or neural network compression framework. So all these tools are available for us to make sure that the model is optimized and it is lightweight for the production needs. And at the end, you can deploy your models on using the OpenVINO runtime on Intel hardware for your edge devices. So that's your production environments, and where your models are being deployed and they will be served. Now, these are a few of the resources which you can take help to get started. OpenVINO Toolkit. The second is Intel Developer Catalog. This is more like it's also called Edge Software Hub. So it's a repository of all the ready to be deployed solutions, and they are really optimized solutions which can be readily downloaded and it can be used in your for your feature building and for your application building. The next is Intel DevCloud for edge workloads. So it's more like a sandbox. Once you have built your model, how do you test it on Intel hardware? So Intel DevCloud helps you in different ways. You can test your edge workloads on the hardware of your choice and then take a right decision. So the next is NLP and dynamic shapes. How is OpenVINO Toolkit working on the NLP use cases, and what is dynamic shapes? So first up, where do we use NLP today? We are using NLP in multiple use cases. Let it be a chatbot or document inferencing. You are doing name entity recognition, or you're extracting information from documents. Everywhere NLP is being used. So as a very simple example is that you have a document and you want to extract entities from the document. So all these are different use cases of NLP where natural language processing is being used. Now, what if you have input data with different shapes? So imagine that the input which you're giving to your application, uh, it has input of varying lengths. It can be a four-worded input, or it can be a multi-worded input. So that is something which is called as input, different input shapes which your application is receiving. So static shape versus dynamic shape means is that uh, the conventional static models, the reshaping works really well, where it can be done once per many model inferencing calls with the same shape. So static shape means that you have built one model, and based on the static shape, based on the static input which you are receiving, your model is able to serve them in the best way. Dynamic shape means is that the input which your model is receiving, it may change on every inference call. So so any use case which you're working with, let's take an example of uh, document inferencing. Let's say you are putting one document as an input to your application. This document can contain 5 words, or it can contain 100 words, or it can be many more. So that's something which is dynamic shape. So this is an example of dynamic shape input. So let's say you have a single line, and you're extracting entities from this input. So you have, let's say you have the location, you have the time, and for the first example here, it was a simple, a few words, a sentence. But the second example which you have on the bottom part, it is a much wider, it's a very long paragraph which contains lot of information. So your aim is to extract entities from this text. Now the text is varying, the text is dynamic in nature because the input size is changing. So so that is what a dynamic shape input exactly means. Now, what happens when you use when you're solving an NLP problem without dynamic shape feature enabled? So, can you, if you can see on the left hand side, you have inputs, and then you are padding your input to make sure it matches a certain length. So, so that is what the inferencing has to be. That is how the inferencing has to be if you are not using dynamic shapes feature of OpenVINO. So in this, the disadvantage of padding is that it reduces the performance. It adds some overheads to your application. So now with dynamic shape feature, if while you are using OpenVINO toolkit, if you enable this feature, how internally it optimizes the performance of your model is that it it doesn't pads your input anymore. It just takes uh, your input string in your input tensors which are coming into the model, and it is able to serve all the dynamic shape capabilities into the model inferencing. So this is one of the features which recently in OpenVINO toolkit the team has launched, and this is one of the great features which has a lot of benefits in especially the NLP use cases. Now let's take an example of dynamic shapes code. So first line, if you see, we are importing the OpenVINO runtime. So the core of this OpenVINO runtime is just like it's the master package of OpenVINO, which is responsible for all the core functionalities of OpenVINO. And then we have dimension. Dimension uh, is the one which will help you to define how to handle dynamic shapes while using OpenVINO. So you load your text, and then you initialize your core object of the OpenVINO runtime, and now you're reading your model. So if you see here, there are two components which you're reading in the model: XML file and the bin file. These are called the intermediate representation of your model, which is a optimized version of your model in terms of weights and all the how the mathematical representation and how the layers are stored in an XML and a binary file. Those all are part of this. So reading the model, and then you take the inputs from the model. Now when you're taking the input into the input layer, you are calling it out as a partial shape. So that means your shape is dynamic in nature. Now, how you're defining the shape here in this example, you can see dimension 1 comma 736. That means I'm telling to my application that my input dimension can be in the range of 1 to 736. And if, let's say, here I am able to predict that what will be my upper limit of the shape, but let's say if I am not aware about the upper bound of my input document shape, input text shape, I can just say -1. So when I say -1, that would mean that I'm not I've still not computed, it is not, we are not able to compute the upper bound. uh, Let the application internally optimize the performance and handle the dynamic shapes internally. And then the model reshapes itself. It is advised to reshape itself as per the input. And then you compile your model. And if you see here, there's an argument called device name. So this can be simply done on a CPU. Right now, in the release which happened in the last quarter, OpenVINO 2022.1 release, dynamic input shapes runs on CPUs, and it is really performing well on all the CPUs for the dynamic shapes. You can learn more about dynamic shape following this QR code. Now you can also use dynamic shapes for vision problems. Let's take an example of optical character recognition. So in this problem, it's a vision problem, as well as it's also a NLP problem, where first the objects have to be identified, and then they have to be even read. So dynamic shapes can also be used on computer vision problems. Now, this is one of the examples of a dynamic shape pipeline. So imagine that you have a document which is just a receipt. Now, dynamic shape for vision means that you are performing an OCR operation on this document, and then you are able to extract the named entity recognition part. So if you see here, dynamic shape for NLP, that is NER. So NER means named entity recognition, and you are able to extract all the named entities from this document, and then you are able to digitize and structure it into let's say a JSON form, and maybe a dictionary. So this is a digitized and structured text. So this is an example of where a dynamic shape pipeline can be very easily used. It's a combination of vision in terms of optical character recognition, as well as NLP in terms of named entity recognition. Now, let's look at the problem analysis. Like, why do we need this dynamic shapes, and what is the problem with static shapes? So, dynamic shape inference consumes huge memory than static shape inference. Uh, so the problem with dynamic shapes is that it shoots up the memory consumption really high if it is not handled really well by the inferencing platform, by the inferencing acceleration technology. So we had an example where dynamic shapes were taking like 7.5x memory, and it was crashing the memory consumption. And so technically, what are the issues with static shapes? So if you see here, edge memory reuse policy is done in graph loading stage. So when you are doing inferencing of NLP models on the edge, that means on in the production environments, your memory usage has to be optimized. But the problem with dynamic shapes is that because you are not able to identify the memory usage during the graph loading stage, so what happens is uh, your the memory size info is loaded at a very later stage, and all the edge memory allocation gets delayed to the graph execution stage where no memory can be reused. So the memory reusing part is actually causing the trouble where we are not able to reuse the memory efficiently. So in this bottom diagram, you will be able to see that you have a memory size, how it's increasing, and the execution order. So you have instructions coming in one by one, and because your instructions are of varying length, you are not able to optimize your memory consumption because you are not aware about the input size beforehand while you are allocating the memory space. So static shape memory usage is actually incrementally increasing the amount of memory consumption. So that's the problem with dynamic shapes. That's the problem with handling if we are not handling dynamic shapes very efficiently. Now, the inference solution for dynamic shapes, how OpenVINO supports it and it does it very efficiently, is that the static shape which we are having, the big memory block, it has to be divided across smaller memory blocks, and that is what how a dynamic shape is handled internally. Now, what we do is we create a dedicated memory manager for each subgroups for managing the memory block, and then we calculate the chunk size, and then at the time when the edge inferencing is happening, at the time of the actual predictions to be launched, we get its memory from the memory manager. That is how this whole breaking up of the static shape is done internally. The biggest challenge and the thing which is the most challenging thing in this is that how to form the most optimal grouping of your memory blocks, because the memory size information is missing at the start. So those are the things where a lot of research goes in, and the team builds the solution. So next up is NLP examples using OpenVINO. So these are all the different famous popular use cases and models which OpenVINO toolkit supports. So the first one is a PyTorch based trained model, which is a Hugging Face bird model. It uses it compares the meaning of sentences. So this is the one form of the NLP model, and you can easily find it on the GitHub on the OpenVINO Notebooks repository. I'll be sharing all these links later on. So this particular example helps you to understand the meanings, identify the meanings of two sentences. So that is what this helps in. This is one example. The next step is text detection and recognition. So this is also one of the example where you are identifying the text, and once you have identified the text, that is more like a computer vision problem. You have to then recognize those texts as well. So you're able to extract out the text from the images or from the computer vision sources. So this is also one of the examples which you'll be easily able to find it on the uh, OpenVINO notebooks. Third is the OpenVINO notebook, which is for speech to text. So we are using this QuadsNet model, which has been optimized for the purpose of automatic speech recognition. The design is based on Jasper architecture, and it's a CNN model. And dynamic shape is playing a very important role here to reshape the duration dimension of input. So when we are handling speech input, that time the duration of that speech is dynamic. The speech can be of varying lengths. So the dynamic shape implementation comes handy in this. The next is the NLP models which we are building, which the samples are available on the GitHub. The first step is generative pre-trained transformer. So we have GPT-2 model which can be used for producing text, automatically producing synthetic text. That this is one of the famous models available for you to try it out. The next is the knowledge graph embeddings model called conv-e. So this is also this sample is also available on the OpenVINO notebooks. So when you go to these notebooks, you will be observing that using OpenVINO toolkit, you will be able to see how the at the runtime latency and throughput performances are enhanced of all these knowledge graph inferencing and prediction tasks which happen. Next is question answering use case is also available on the GitHub OpenVINO notebooks. You'll be able to see how a squad-tuned BERT model is used for efficient question answering using OpenVINO, and how this use case is also served well. And then we have a named entity recognition notebook available, which you can try out for information retrieval and extracting out the entities from the text. This notebook demonstrates entity extraction from simple text using squad tuned BERT model from the Open Model Zoo. Now, just a little zoom on the NER problem and how OpenVINO supports NER. So when you go to the notebook, you'll be able to see how a simple text is pre-processed and then it is passed through the model, and then some processing happens to extract the entities with context and confidence scores. So which is like a JSON object which is produced at the end. Now, this same pipeline, you will be able to see how OpenVINO helps in doing it more efficiently. So when you are building a production application which does name entity recognition, and for production inference acceleration, you need some technology. OpenVINO will be your toolkit to try it out. And this can be extended even further from a simple text to even documents. So documents can be an image file or a PDF file. And so you first perform an OCR operation on those files. So there might be many packages which you can use for performing the optical character recognition. And then the same pipeline can help you to perform the extract the text out of the documents, then pre-process them, pass it through the model, have the best inference acceleration, and then extract the entities in terms of the context and the confidence scores. So this is one of the pipelines. At the last, we have all the resources to get you started. Just visit OpenVINO Notebooks, which is the Intel OpenVINO Notebooks repository, where you can find a lot of use cases. All the use cases are available. Try out the Intel Edge AI certification program. You can learn many use cases there. There are a lot of trainer videos available, and you can also enroll for the Intel Edge training to learn more about the how Intel technologies help for edge deployments, edge inferencing, and inference acceleration. So that's all from my end. Thank you so much, everyone, for joining this session. Thanks.